Hello everyone, let's talk about today again, but today we will focus on pointers arithmetic. So how when we like cross pointers by 1 or 2, what happened? Let's see it. Okay, so if we have pointers, for example, we have an integer star y, which is equal to address x, and we have an integer x, which is a variable. Okay, so in memory, the x should be somewhere here, and the value should be 0. And let's some address for this x, for example, 204a. And of course, this is for x. And we have another one for y. Y is here, and y's value is 204a, which allow us point to this data, right? So, okay, so the address is actually the number. Yeah, address is a number, right? So 204a is a number, and you can have different number. So do you think about it? Like, do you imagine that maybe because it's a number, so maybe I can use arithmetic, some operations. I can do a subtraction, or I can do sum up a product of this memory address, right? So if I do it, what happened? Okay, let's see this example. If I have y equal to 204a, then I say y plus plus. What happened? Okay, so the first idea, which is, okay, because y equal to 204a, so after y plus plus, it should become to 2049, right? But actually, C compiler doesn't do it. C compiler will use your size, the size you point to. So right now, this pointer y point to a, a, a data, the type is integer. So based on the data, which is integer, so it won't be 2049 here because the C compiler provide these pointers arithmetic to support some traversal, some iterations. So what this will be? So you see y plus plus, but actually you can treat it y plus size of integer. So actually it's become 2052. So if you do y plus plus here, it will be 2052, not 2049. Okay, but if we change it, if right now this is non-integer, this is a character pointer, and we do a y plus plus, then because it's character, so it's plus 1. So it's not, it won't be 2052 anymore. It will go back to 2049. So based on the type your pointer point to, it will use the size of the type plus to y to do it. Okay, so in this case, let's see another example. Right now, we don't want to do y plus plus, and it's a character. Okay, so if the pointer point to a character, okay, assume this is a character, and this, of course, this is a character too. Okay, so in this case, we say y plus 5. If it's character, it's equal to y plus 5 times size of character. So it's equal to 2053. Yes, it is. But if we change the character here, we change it to integer, it will change it here to be integer. So it will become y times plus 5 times size of integer, which is 4. So it will be 2068 because 2048 plus 4, 5 times 4. So this is 20. So it will be 2068. Do you get the idea? The same thing happened in subtraction. If we do the minus number, for example, we do this, we minus 5, it will become 2028 because 2048 minus 5 times 4. Okay, so you got the idea. So when you do a pointers arithmetic actually you use the size of the type is 0.2 to do these operations. So because of this feature, these special features we have, right now we can use pointers to support the array iteration, a traversal. Okay, so right now I give you an array. Okay, so you know in memory, the array will be look like this. For example, if the address for this array is 2048, this will be A0, A1, A2, A3, and so on until A9. Okay, so in this case, we can use pointers to do a traversal. How? First one, we will say we have a pointers star ptr equal to the address of A0, the address of first element, right? Then it doesn't matter is an integer, character, or something. When we do star ptr, not star ptr, we do ptr plus 1 because if this is 2048, 2052, we do ptr plus 1, it will point to the second one. Then we do a star. Actually, this is equal to A1. Okay? So we can do it. We can also do star ptr plus plus, and we just keep doing it. Then it can traverse from here, 0 to 1 to 2 to 3. So actually, star ptr plus 1 equal to A1. Star ptr plus 2 equal to A2. Clear? And you probably don't know what's the address for array. Actually, when we say A equal address of A0. So A array is actually a pointers in C languages. So the name of array actually is equal to the address of the first element in the array. So we can change it to this format. ptr equal to A. That's it. Because A equal to address A0. Then we can do this. We can do a traversal by using this. ptr address plus some number. Then when this start, open it. Then we can find out what's the value in the array. Okay? Do you think it's magic? Actually, it's really, really useful, especially if we will talk about dynamic allocations in the future. These arithmetic in pointers will be really, really useful if we can do these dynamic allocations. Okay, let's together to see this example. The example I create an array. I use a pointers equal to this array. Then right now I assign the 100 to array 5, which is the 6 elements in the array, and I print out it. And here I assign the pointer plus 5 equal to 200, then I print out the 6 element in the array again. So we should see the difference. We should see the array is updated by this pointer stuff here. Okay, so let's look at what's the result here. So we can GCC pointers and arrays -o pointers and arrays. Then we execute it. So you can see 100, 200. So when you use pointers operations, these operations, you can actually update the value in the array. Okay, so you can use pointers point to the memory for this array, use this operation to iterations. Okay, so let's see another example. Okay, here there's a for loop. So inside this for loop, I try to traversal. I do an iteration from 0 to 9. Then I assign I to the array. And right now, I can show you when I do this, every time I assign value, I try to print out percent I space the PTR, the value PTR, and I dereference it. I open the box, so I should get the value. Then after I print out the value, I do this. Values PTR plus plus. So I update it. Okay, so let's see what the result should be. You can see actually it's print out each iteration, the value, each value in the array. So it's still the traversal in the array. Okay, so again, GCC pointers array -o pointers and run it. So you can see it traversal from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 by using these arithmetic of pointers. Okay, so it's really useful, right? Okay, so let's practice with another example. Okay, so right now we have a special character, which is character pointers, and we have a variable name day, which is array. So we have an array of character. Okay, we have an array of character pointers. And these array of character pointers, because these character pointers, you can imagine that it's kind of string. So array of string. So the array of string, the first string is Sunday, the second one is Monday, and so on. So here's the memory will be look like. So first one, we will have a day here. This is day. And we have a memory address, let's say 204A here. And this is a pointers because it's an array of pointers. So this is pointers, this is pointers, this is pointers, okay? The first pointer point to somewhere. The second pointers also pointer to somewhere, okay? So for the first pointer is point to the string. So inside this string, so you can see this pointer can be something like this one, S, U, N. And for example, if this is this address, you will see 0240 here. And of course, the next one, green one, is Monday, and O, and N. So for this one, if this address is 20480, this will be 20480. Okay, so this is the array of string. So right now we have a special term. It's star star character PTR. Oh, sorry, it should be character star star PTR. So it's a pointer point to a character pointers PTR equal a. Okay, so what's the value of PTR plus 1 star star? Let's think about it. Practice. Okay, so we know PTR is PTR point to day. Day is array. So what's the array? What's the array means? This is address of day 0. So address of day 0 is this one. So actually we can get PTR is 02048. And we know it's plus 1, means it's plus the size of character pointer, because the size of this array, the size, the type of the type inside this array element is the character pointers. So if it's in 32-bit machine, it will be 4 bytes. If it's in 64-bit machine, it will be 8 bytes. So if assume this is 32-bit machine, okay? In this case, it's 4 bytes. So the next one will be 22, 40, 52. Okay, so let me make it clear. So this one will be 2242. Okay, so this will be a size 4. So in the end, when we got 2048 plus 4, we will got 2052. Okay, so we got 2052 will be the address. So right now we open this address, okay? Right now we just get the address 2052. So when we open this 2052, we open it, what's the value we got? We got the address 2052, we open the box. So we got this value, 20480, right? So actually everything here is got equal to 20480, okay? So we got this address and we still want to open it. Okay, when we open it, what's the value? 20480, we open it again. So let's see, we open it again, 20480, point to here. So when we open it again, it's written n. Okay, so actually the star star parentheses PTR plus 1 equal to character n. Okay, so here's the idea. If we want to print out this one actually is a first character in the second string. If we change this one to another value, we change it to 3, it will be the first character of the fourth string. Okay, so you can see it's so magic. We can just play around with these pointers, arithmetic. Then we can just like traverse like each array, go to different string, go check different characters. It's interesting, right? Okay, so this is for today. Today we covered how to use arithmetic operations on our pointers, and to make it more powerful, to use it to support some traversal iteration in your memory. And it's really complicated. You probably need to give yourself some like example to play with this, then you will get familiar with this. And you will see this is really useful when we cover dynamic allocations. Okay, so I hope you enjoyed today's lecture, and see you next time. Pointer arithmetic is awesome.